Good afternoon, everyone. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haryana. So in the previous class, we were discussing about solving second-order differential equations numerically using Runge-Kutta method and Milne's predictor and corrector method. So we have discussed how to reduce a second-order differential equation to first-order differential equation, then how to solve it using Runge-Kutta method and how to solve it using Milne's method we have discussed in the previous few classes. So we are learning only two methods, that is Runge-Kutta method and Milne's predictor and corrector method to solve a second order differential equation. By now you must be thorough with how to convert the second order differential equation to first order differential equation by making the necessary substitution. Is it so? Is it everyone?
Yes, ma'am.
Okay. So let's move on to the next topic what we are discussing, that is calculus of variation. This calculus of variation is required in dynamics of rigid body, optimization of orbit vibration problems, maximizing or minimizing functionals. This calculus of variation is useful, and there are some problems on category. All those problems we are discussing. We are not discussing all those problems, but in somewhere we require this concept of calculus of variation in order to solve certain kind of problems. So let's first discuss what do you mean by functional. Before that, we'll discuss what do you mean by function. You have learned the concept of functions, isn't it? All learned the concept of functions in set theory. You all have learned what you all know what you mean by functions. You all know all these things. You have learned about this. So what do you mean by a function? You have a domain, correct? Domain and codomain. Domain and codomain. Here this we have one set, this is one more set, A to B. So when do we say that there exists a function f? When do we say that there exists a function f? When can we say that a function is defined? Function is defined, we can say that if every element in the domain has an image in the codomain. A is mapped to say A dash, B is mapped to B dash, C is mapped to C dash, D is mapped to D dash. So every element in the domain is mapped to a unique element in the codomain. Every element in A assigns a unique image or unique element in B. Then we say that there exists a function. We can define a function only in such cases. We can define a function only in such cases where unique element of A is mapped to unique element of B. You cannot have two images for a single element. That means A cannot be mapped to one more element. Then it is not a function. This should not happen. Every element of A must have a unique image in B. Then only we can say that we can define a function, or else we cannot define element of A cannot, it cannot to codomain, cannot be mapped to two elements in the codomain. Then you cannot define a function. A function is defined only when unique element is assigned to a unique element in the codomain. So this is regarding function. We know what is a function. Then here we are discussing in calculus of variation, we have the concept of functionals. So what do you mean by functional? Functional is similar to the concept of functions. Functional is similar to the concept of functions, where here I have elements, say numbers A, B, C and D, where in the case of functionals we have all the functions. Our domain will be the set of functions. Our domain will be set of functions and codomain is the set of real numbers. Set of real numbers. So here there exists a mapping from this domain to codomain. We can say that this is termed as functional. functional. So this is what, this is a function where all the elements are numbers, real numbers. You can take real numbers or any rationals, irrational. So here every element is mapped to a, which assigns every element of the domain to a unique element of the codomain. Then it is termed as a function. In functional, what happens? The domain contains the set of all functions. Domain contains the set of all functions. Suppose if every function in the domain assign a unique element of the codomain, then we can say that it is a functional. So what do you mean by a functional? There exists any function which assigns to each function in this domain a unique real value in the codomain. Such type of functions is known as functional. I hope this concept of function and functional is clear. I hope you are able to differentiate between function and functional. Functional, you have all the elements in domain, but whereas in functionals the domain contains the set of functions. So suppose if set of function, each set of functions in the domain assign a unique real value, then we can term that as functional. Anybody, any doubt in function and functional?
No, ma'am.
Okay. Then now we will discuss more about this. Suppose if you consider a function which is of the form, say f of x comma y dash, where y dash is the derivative of y. Y dash is the derivative of y with respect to x, where x is a function of two variables. Say it can be written as x1 comma x2. Then the integral, if you can write this as integral x1 to x2 f of x comma y dash into dx, this is known as the functional. This functional can also be written in terms of the integral values from x1 to x2 f of x comma y dash into d dash. This is your understanding what do you mean by a functional, and functional is given by this definite integral. Functional is given by this definite integral. Now there is a property of variations, of variation. So suppose if there is a slight variation, delta stands for variation, slight variation in dy by dx, this is nothing but the slight variation in the variable y. Slight variation in the derivative is equal to d by dx of slight variation in y. This is one property which you need to remember. Now, suppose, say for example, I can take this as one example I can give. Suppose if I is given to be integral x1 to x2 f of x comma y dash into dx, then how can you apply this property and write? How to apply this property? This property can be applied as delta, small variation in the functional. A functional is integral x1 to x2 f of x comma y dash into dx. That is nothing but integral x1 to x2, a small variation in f of x comma y dash into dx. This is by applying the property. By applying this property, slight variation in this functional can be given by the slight variation in the function. Okay. Now, what we can actually say with this, the variational of a functional, this is a functional, the variation of a functional with f of x comma y dash is equal to the functional, see functional is represented in terms of this definite integral. So it is equal to the functional associated with the variation of f. I hope you are able to understand the meaning of this. I repeat once again, so delta stands for variational and the definite integral stands for the functional. Okay, the definite integral. Functional is always given in terms of this definite integral, and delta stands for variation. So what you can say, variational of a functional associated with f of x comma y dash is equal to the functional. Integration stands for functional. Functional associated with the variation of f. So this concept we require when we are going to prove the Euler's equation, which is a very important thing what we are learning here. So let's next we discuss in calculus of variation how to determine the function say y equal to y of x which satisfies certain conditions, say y of x1 equal to y1 and y of x2 is equal to y2 such that a given function f of x comma y dash, I can take this as say I of y, definite integral, it attains extremum. It attains extremum. See, in our lower classes we have discussed differential calculus. In differential calculus what do we discuss? We discuss the concept of maxima and minima. Maxima, minima, extremum, minimum. We have learned this. Remember, we have used some methods. We have used the concept of Lagrange multipliers. We have used some methods to find the maxima and minima of functions. Okay, maxima and minima of functions we have found out. Here in calculus of variation, we deal with the maxima and minima of functionals. Okay, in calculus of variation, we deal with the maxima and minima of functionals. So for that we need a necessary condition. The necessary condition I of y. I of y stands for what? Functional, which is given in terms of definite integrals. Here we are going to deal with the maxima and minima of functionals, and there is a necessary and sufficient condition for the functional to attain extremum. Functional to attain extremum. Extremum, and which is obtained by Euler's equation. Which is obtained by Euler's equation. So this is what we are going to learn in the beginning. Okay, everybody clear? Is it clear, everyone?
Yes, ma'am.
Hope you all can see the screen.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
No, check your internet connection. Okay. So we shall begin with, till now we were discussing about, correct? We were discussing about what do you mean by functional? We have discussed what do you mean by functional, and what else? We need a necessary condition. We need a necessary condition for the functional to achieve the extremum, which is obtained by this Euler's equation. So let's derive this Euler's equation. It is a very important concept here, Euler's equation. So now, what does this Euler's equation say? A necessary condition for the integral I equal to x1 to x2 f of x comma y dash into dx, where y of x1 equal to y1, y of x2 equal to y2 to be an extremum. To be an extremum. Necessary and sufficient condition for this functional to achieve the extremum is that dou f by dou y minus d by dx of dou f divided by dou y dash equal to 0. So this is the statement. This is what Euler's equation says. This is what Euler's equation says. It gives us the necessary condition for the integral or the functional. This is the integral, which can also be termed as functional. with the conditions y of x1 equal to y1 and y of x2 equal to y2. With these conditions, suppose if this integral achieves the extremum, then this must satisfy this condition. This is the necessary condition for the functional to achieve extremum. So suppose if someone asks you how to find that, how to check whether the functional achieves an extremum, this is the necessary condition. This is the must condition. You need to check this one. If this satisfies, then you can say that the functional attains its extremum. So now we shall prove this. With that, suppose consider this figure and you have a curve. I consider a curve, say y equal to f of x. This is the curve. Okay, this is the curve y equal to f of x. Initial point is P, end point is Q. Then I consider one more curve. Okay, a neighborhood of the previous curve. I consider one more curve and I consider the equation of this as y of x plus h times alpha x, a slight variation in the previous one. So this is, if you take this as this curve, if you take it as y of x, so if I take y equal to y of x, this curve will be a slight variation in the previous curve. Okay, this is the curve y equal to y of x, so this will be y of x plus h times alpha x. This h times alpha x is the slight variation. Okay, now suppose if I consider the points x1 and any point over here, if I take it as x and one, let's take this as x2 because our integral vary from x1 to x2. Let's take this length as y1, this length as y and this length as y2. P will be x1 comma y1 and q coordinates will be x2 comma y2. So this is just the figure. Now we know that I means what? This integral. This attains the extremum along some curve, say y equal to y of x. I say that this integral attains its extremum along the curve y equal to y of x, which passes through the points p of x1 comma y1 and q of x2 comma y2. Okay, our integral I attains the maximum along this curve y equal to y of x, where the points which passes through the points P and Q, P of x1 comma y1 and Q of x2 comma y2. Now we consider one more curve. We consider one more curve. So I take that as, let y equal to y of x plus h times alpha x. So this is our another curve, h times alpha x. This is the neighboring curve which joins the points P and Q, which joins the points P and Q. Now just check this. We have considered the curve y equal to y of x plus h times alpha x. This is the neighboring curve joining the points P and Q. So that now suppose if we say that these two are equal, suppose if these two curves has to be equal, then we must have value of alpha x1 equal to 0 at P and alpha of x2 also will be equal to 0 at Q. Okay, so now what happens? Why is this? These two are the points. See, y equal to y of x plus h times alpha x. H times alpha x is a slight increment. We have considered this curve as the neighboring curve of this. Okay, it also passes through the points P and Q. Suppose if this curve passes through the points P and Q, then you can say that at the point P, this alpha x1 must be equal to 0, and at the point Q, this alpha x2 must be equal to 0, because this curve also passes through the points which is same as y equal to y of x. Above on this curve, you might get some values for alpha x, but at the point P, alpha x1, coordinate of x is x1 over here, so at the point P, alpha x1 must be equal to 0. At point Q, alpha x2 must be equal to 0. Then only we will get y equal to y of x. I hope this is clear. Is it?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
so let's take this as 1. Let's take this as 2. Now, so what happens when h is equal to 0? What happens when h is equal to 0? Suppose if this h is equal to 0 at all the points on this curve, at all the points on this curve, suppose if this h becomes equal to 0, what do we get? Two curves coincide, because this also y equal to y of x, this also will become y equal to y of x when h is equal to 0. So when h is equal to 0, these two curves coincide. When these curves coincide, what we get an as the extremum. I attains the extremum. When h is equal to 0, I attains the extremum. So you can write the integral I as integral vary from x1 to x2 f of x comma y of x. See now, our equation is y dash. Okay, y dash, and y of x, you can substitute this y of x plus h times alpha x comma y dash will be what? See, if this is y is equal to y dash plus h times alpha x, what will be y dash? Y dash will be y dash of x plus h times alpha dash of x d. This is what we have got it by substituting the value of y and y dash. Y curve we have over here, y dash is obtained by differentiating. Now what happens? This attains the extremum. This curve attains the extremum when h is equal to 0. This entire integral, all the functional, attains its extremum when h is equal to 0. When this slight variation becomes equal to 0, two curves coincide. So when two curves coincide, we will get an extremum. Now what we need to do is, to acquire this, we need to find di by dh equal to 0. So you can see this clearly. If you take I to be a function of h, if you take I to be a function of h, when this happens, when h is equal to 0, when h is equal to 0, you get this I to be a function of h. When this h is equal to 0, this I will be a function of h. That's why as I is a function of h, you get di by dh is equal to 0. You first differentiate this I with respect to h. What we get? Di by dh, that is equal to integral x1 to x2. We have to differentiate now. So see, it's partial differentiation we have to use, because we have here x, y dash. It's a function of three variables. So you have to use partial derivative. This is the sign which stands for partial derivative. So dou by dou h of f of x comma y of x plus h times alpha x comma y dash of x plus h times alpha dash of x into dx. So this is what we have to do. We have to differentiate. We have to use partial differentiation. After partial differentiation, now apply chain rule. We have learned chain rule as well while discussing partial differentiation in the previous semester. So di by dh will be integral x1 to x2. What will be the partial differentiation? F is a function of x, y dash. Correct? F has x, y and y dash, and moreover we are differentiating I with respect to h. So when you apply partial derivatives or the chain rule for partial derivatives, what do we get? Dou f by dou x into dou x by dou h plus dou f by dou y into dou y by dou h plus dou f by dou y dash into dou y dash by dou h into dx. This is the concept of chain rule. You have a function f which has three variables x, y and y dash, and we are differentiating with respect to h. That's why it is dou f by dou x into dou x by dou h, dou f by dou y into dou y by dou h, dou f by dou y dash into dou y dash by dou h. This is using chain rule. Let's take this as third equation. Now we know h is independent of x. H is a constant which does not dependent on any of the things. So that's why we can say that dou x by dou h is equal to 0, as h is independent of x. H is independent of x. independent of x, dou x by dou h is equal to 0. Now what we do, we shall take this 1 is what, y is equal to y of x plus h times alpha x. So when you differentiate that, differentiating 1 we get y dash is equal to y dash of x plus h times alpha dash of x. Let's take this as 4. Now if you differentiate that y, what is y? Y of x plus h times alpha x. Now if you differentiate this y with respect to h, what are you going to get? Differentiate this y with respect to x. When you differentiate y with respect to h, this will become 0 because we are differentiating with respect to h. So what do we get? Only alpha x, because differentiation of h will be 1. So dou y by dou h will be alpha x. Now from this one, from 4, dou y dash by dou h. What will be dou y dash by dou h? We are differentiating this 4 with respect to h. So this term will be 0. So this term will be alpha dash of x. Now use all these results, whatever results we have, substitute over here. This result, substituting in 3. So what do we get from 3? When you substitute all these things in 3, what do we get? Check what do we get. So di by dh will be, di divided by dh will be integral x1 to x2, see dou x by dou h, this term will be 0. The second term, dou f by dou y, dou f divided by dou y into dou y by dou h. Dou y by dou h is what? Alpha x. So we get alpha x plus dou f by into alpha dash of x will get, because dou y dash by dou h is alpha dash of x into dx. So let's take this as equation 5. Now we have to find the integral of this, so that we can use integration by parts. So what we shall do is, we keep the first term as it is, dy by dh integral x1 to x2. The first term we keep it as it is, dou f by dou y into alpha of x. Then we shall apply integration to the second part. You use integration by parts. Integration by parts. So take this as the first term, take this as the second term. So what it will be? First term into what? First term into integration of the second term. So what is our first term? You can write it, d dou f by dou y dash. This is our first term. Hope you all know integration by parts. First term into integration of second. What will be integration of alpha dash? What is the integration of alpha dash of x?
Alpha x.
Alpha x. So it is dou f by dou y dash into alpha of x. So the first part is over. Then minus, we have integral of x1 to x2, or you can also write it as, if I say by Bernoulli's rule. Bernoulli's rule, first term into integration of second term. Then what we do, we'll write the integrated term as it is, alpha of x. Then we integrate or the differentiate the first term. We have to differentiate the first term. Integration of second term, that is integration of x1 to x2 into differentiation of first term, that is d by dx of dou f by dou y dash into dx. I hope this integration by parts is clear. I repeat once again. So here I have considered, see here, we have to first term keep it as it is, dou f by dou y into alpha of x. First term keep it as it is. Apply the integration on second part. Apply the integration on second part. So if I consider dou f by dou y as first term, alpha dash of x as the second term, it is first term into integration of second term. So integration of alpha dash is alpha of x. Then minus integration of the integrated term. So integration of the integrated term, that is alpha x, into differentiation of the first term. So d by dx of dou f by dou y dash into dx. I hope this is clear, everyone. Yes?
Yes, ma'am.
Okay. Next. Now what we shall do? Now let's simplify this. We have integration x1 to x2 dou f by dou y alpha of x into dx. This dx is that. Okay, alpha of x into dx. Here dx is missing. Then plus simplify the remaining terms dou f by dou y dash into. Now here we have to put the limits x1 and x2. So it will be what? Alpha of x2, upper limit is alpha of x2 minus dou f by dou y dash into lower limit is alpha of x1. See, this was the first term, for that we need to put the limits. So we have put the limits. So after putting the limits, check the second term. This is the term which is pending. Integral x1 to x2 alpha of x into d by dx of dou f by dou y dash into dx. Anybody any doubt till this step? Anybody any doubt?
No, ma'am.
Okay, this is very important, everyone. Please be careful. Listen to me carefully. Okay, now from this, see, we have from 2. What we have from 2, there is equation 2. See, here is the equation 2, where alpha of x1 equal to 0 at p, alpha of x2 equal to 0 at q. So we have these two conditions which we are going to put over here. So from 2 we have alpha of x1 equal to 0 and alpha of x2 0. So when we substitute this in the above integral, what we get? Di by dh, that is equal to integral x1 to x2. The first term will remain as it is, dou f by dou y into alpha of x dx. So alpha of x to 0, alpha of x1 equal to 0. This entire term will be 0. So next what is remaining? Minus integral x1 to x2 alpha of x into d by dx of dou f by dou y dash into dx. Now you can take the common term. What's a common term? Here we have di by dh, that is equal to integral x1 to x2 dou f by dou y. You can take this integral common. Dou f by dou y is over here, and check what are the terms. Alpha x is also common term, minus d by dx of dou f by dou y dash. So this is the term, and what is remaining? Alpha of x into dx. So this integral and alpha of x are the common term. What is remaining? Dou f by dou y into dx, then minus dx by dx of dou y by dou y dash. So these are the terms which are remaining. We have simplified and written. Now after this, we have said that for the function to attain extremum, di by dh must be equal to 0 when h is equal to 0. When this condition is satisfied, I attains extremum. We require now the functional to achieve extremum value. We want a necessary condition for the functional to attain extremum, and that is possible when di by dh equal to 0, when h is equal to 0. So you can say that this must be equal to 0, that is integral x1 to x2 dou f by dou y minus d by dx of dou f by dou y dash. This integral must be equal to alpha of x dx equal to 0. This must be equal to 0. Now we know this alpha, this is some arbitrary on the curve. See, this is that curve we had. This is y equal to y of x. This was y equal to y of x plus h times alpha of x. At this point, the alpha of x1 and x2 must be 0, because this curve also passes through P and Q. This curve also passes through P and Q. On this curve, this alpha is varying. We will have different values for alpha. Okay, it is completely varying on this curve. As this alpha of x is varying, this is what it varies, and what is remaining, this term is only remaining. So dou f by minus d by dx of dou f by dou y dash. This must be equal to 0. Then only this integral will be equal to 0. So this is a necessary condition. This is the necessary condition for the functional to achieve the extremum. This is that necessary condition so that our functional I equal to x1 to x2 f of x comma y dash into dx. This will attain the extremum. Any doubt in this Euler's equation? This Euler's equation proof is also there in the syllabus, which is very important. Usually proofs will not be there. See, wherever we have discussed numerical methods, all those formulas have proofs. There is a derivation for all the proofs, for all the theorems, but it is not there in your syllabus. So there are only few derivations here as we have derived this necessary condition for the functional to attain extremum. So where this module is very small, there are only few questions and those questions are very important which you need to remember. Okay, so understand the concept and try to derive this on your own. So if you have any doubt, you can ask me. Okay, and based on this necessary condition, we are going to discuss few questions. We are going to check the extremal of some functional. And remember, this functional is given in terms of the definite integral. And what is the meaning of functional? It is a function. Okay, functional is nothing but a function where the domain contains all the functions. Okay, where the domain contains all the functionals. So each function in the domain is assigned a unique real number. Each function in the domain is assigned a unique real number. Then we can say that it is a functional. Try to understand the relation between function and functional. So let's discuss few examples based on this, how to find the extremum using the concept of functionals. Let's discuss about this. So let's discuss this question. Find the extremal of the functional integral x1 to x2 y dash plus x square into y dash square into dx. So this is a functional. Now we need to find the extremal, or you can say that at what value of this functional attains its extremum. That is what we need to find. So it says let f of x comma y dash that is equal to y dash plus x square into y dash square. Okay, this is our function f of x comma y dash. Now we have the necessary condition which we have got it from Euler's equation. So from Euler's equation, what do we have? What is the necessary condition? Dou f by dou y minus d by dx of dou f by dou y dash. This must be equal to 0 in order to achieve the extremum. So now what happens when you put this dou f by dou y? See the function f which has y dash and y dash terms x and y dash terms only. We do not have any term with respect to y. So this dou f by dou y will become 0. See, this function contains y dash and x terms only, no y term. So the dou f by dou y will become 0 minus d by dx of, what is dou f by dou y dash? Differentiate f with respect to y dash. When you differentiate y with respect to y dash, we get differentiation of y dash with respect to y dash is 1 plus x square will remain as it is. Then differentiation of y dash square with respect to y dash will be 2 times y dash. Am I correct? Is it? And that is equal to 0. Any doubt in this?
No, ma'am.
Okay. Now, what do we get? This can also be written as d by dx of 1 plus x. 1 plus, you can write 2x square y dash equal to 0. This is what we get it from applying the necessary condition using Euler's equation. Okay. Now, Now what do? We have to find the value of y. Remember that. First, we shall integrate. Integrating with respect to x. Integrating with respect to x. So what happens when we integrate with respect to x? We get 1 plus 2x square y dash is equal to, what do we get? Equal to some constant. So let's take this as k1. Correct? Integration of 0. 0 is a constant. So integration of a constant is what? Some constant we will get. Am I correct?
Yes, ma'am.
Yes, ma'am.
Okay, now from this get y dash. How do we get y dash? Y dash is nothing but k1 minus 1, correct? K1 minus 1 divided by 2x square. Now let's find what is y. From y dash, if we have to find y, we need to integrate it. So integrate, you take the constant term outside, integration of 1 by x square into dx plus a constant. Let's take this as what? You can take this as any term. Let's take this as some c2 or c1, or whatever you can want, you can take it. Now integrating, what do we get? Y equal to k1 minus 1 by 2. What is the integration of 1 by x square? It is minus 1 by x, correct? Plus c2. Now here this can also be written as y is equal to, if I take this minus sign outside, it will become 1 minus k1 divided by 2 into 1 by x into 1 by x plus c2. So if I take C1 by x plus C, where what is C1? 1 minus K1 divided by 2. Is it clear, everyone? So this is that value where our functional I attains extremum. Anybody, any doubt?
No, ma'am.
Okay. These problems are very simple. Let's discuss one more question. Find the function y. We need to find the function y which makes the integral x1 to x2 1 plus xy dash plus xy dash square dx an extremum. We need to find the value function y for which this integral has an extremum. So how shall we do it? Let's find, let f of x comma y dash is equal to what? What is f of x comma y dash? It is 1 plus xy dash 1 plus xy dash plus xy dash square. So this is that function. From Euler's equation, what do we have? Dou f by dou y minus d by dx of dou f by dou y dash equal to 0. So this is Euler's equation. This is a necessary condition. Now you similarly over here, this f of x comma y dash contains x and y dash terms only. So dou f by dou y will be 0 minus d by dx of dou f by dou y dash. Now differentiate this with respect to y dash. What do we get? 1 will be 0, then x into y dash, it will be x plus this will be 2x into y dash, that is equal to 0. So in other words, what do we have over here? D by dx of x plus 2x y dash equal to 0. 2x y dash equal to 0. Next, what do? We integrate. On integrating, what do we get on integrating? X plus 2x y dash is equal to some constant. Let's take this as k1. So integration and differentiation gets cancelled. So we will get x plus 2x y dash equal to k1. Integration of a differentiation will be the term itself. So now next, I hope this is clear, everyone. Is this step clear to everybody?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay. Okay, now from this, what is the value of y dash? What is y dash from this? It is k1 minus x divided by 2x, correct? And what you can do here is you can split this k1 divided by 2x minus x by 2x. It will be 1 divided by 2. Now from y dash we need to find y. For that what we do? We integrate it again. So integrating, what we get on integrating? Y is equal to, I'll take this as k1 divided by 2 into integration of 1 by x into dx minus integration of half into dx plus the integrating constant. Let's take this as c2. Now what happens? What do we get? Y is equal to, we get k1 by 2. Integration of 1 by x is what? Log x. Integration of 1 by x is log x minus integration of constant terms with respect to x. It is half times x. Integration of 1 into dx is x. Similarly, that integration of half with respect to x is half x. Then we have the constant, say c. Now how you can term this? You can also write this as y is equal to k1 by k2. We'll write it as c1 log x minus x by 2 plus c2, where what is c1? It is k1 divided by 2. So this is the function y for which the functional attains a extremum. Is it clear now? Is it
Yes,
clear
ma'am.
how to check whether the functional attains its extremum? We need to find the value of that function for which the functional attains its extremum. Everybody clear?
Yes, ma'am.
Okay. So what have we discussed in today's class? Today's class we have discussed regarding functionals. Functionals and one property of functional. Then we have discussed the necessary condition for the functional to achieve extremum. That is, we have derived Euler's equation, and making use of this Euler's equation we have solved few examples wherein we are learning how to check, how to find the function for which the functional attains its extremum. If you have any doubt, you can ask me. No? Okay, learn this Euler's equation, everyone. Let's meet in tomorrow's class, everybody. Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.